Introduction. On 4 August 2020 at around 6:08 p.m., a massive explosion occurred at the port of Beirut in Lebanon. The explosion was caused by about 2,750 tons of ammonium nitrate that had been stored at the port for several years without proper safety measures. A fire started and triggered the blast, which destroyed most of the port and damaged nearby buildings, vehicles, and homes. Most than 200 people were killed, thousands were injured, and around half a million residents lost their homes. The explosion could be felt hundreds of kilometers away and caused panic across the city. Investigation later found that the disaster happened due to long-term negligence, poor storage conditions, and failure by authorities to enforce safety regulations, making it one of the worst tragedies in Lebanon's history.
Okay, hello, my name is Subhash Analaki Tanabalan, nometric B122510630. Okay, now I'm going to present about case overview and technical background. Okay, the incident occurred on 4th August 2020 at the port of Beirut in Lebanon. The port is an important area for trade and is located close to residential neighborhood. Because of this, when the explosion happened, it did not only affect the port itself, but also affect the surrounding communities. Then the main cause of the explosion was a storage of around 2,750 tons of ammonium nitrate in a warehouse at the port. Ammonium nitrate is a chemical commonly used in fertilizers, but it can become very dangerous if it is not stored properly. In this case, the chemical was kept in a warehouse for about 6 years without proper safety control, inspection, or monitoring. On the day of the incident, a fire broke out near the warehouse. The heat from the fire eventually caused ammonium nitrate to explode. Okay, the impact of the disaster was extremely serious. More than 200 people lost their lives and over 7,000 people were injured. Around 300,000 residents lost their homes due to the explosion. Many buildings were badly damaged, including houses, hospitals, schools, and many important port infrastructures. The explosion caused fear, panic, and long-term disruption to daily life in Beirut. From a technical point of view, the incident clearly shows a failure to safety system. There was no proper inspection or monitoring of the stored ammonia nitrate, even though it was known to be hazardous chemical. In addition, there was a lack of clear safety procedure for handling and storing dangerous materials. This failure allowed the risk to grow over time and eventually lead to this disaster. Overall, this case shows how poor safety management and negligence in handling hazardous materials can result in serious consequences for both people and infrastructure. Thank you.
The 2020 Beirut explosion began in November 2013 when the Moldovan cargo ship MV Roses carrying 2,750 tons of ammonium nitrate was forced to dock at the Beirut port due to technical and financial issues. By October 2014, the vessel was officially abandoned and its hazardous cargo moved into Warehouse 12, where it remained the next 6 years, despite at least 10 warning letters sent by customs and security authorities highlighting the immense danger of the ammonium nitrate. No corrective action was taken. On the evening of August 4, 2020, welding work being conducted in the warehouse sparked a fire that ignited stored firework, which in turn triggered the massive detonation of the ammonium nitrate at 6:08 p.m. The resulting explosion on the large non-nuclear blast in history caused 218 deaths, 7,000 injuries, and displaced 300,000 people while causing $15 billion in property damage. In the immediate aftermath, widespread mass protest erupted, leading to the resignation of Prime Minister Hassan Diab's government on August 10, 2020. Since then, the national injuries led by Judge Tariq Bitar have been repeatedly suspended and blocked by political obstacles and implicated officials.
This slide explains the main stakeholders involved in the Beirut explosion. It focused on their roles and responsibility and how each group was affected by the incident. First one, Lebanese government. The Lebanese government is one of the most important stakeholders because it is responsible for public safety, national infrastructure, and law enforcement. Several government ministries were involved in managing and regulating the port of Beirut. After the explosion, the government faced strong public criticism, political instability, and the resignation of the cabinet due to the failure in regulation and oversight. Second one, port authorities. The port authorities were responsible for managing daily operation at the port, including the storage of hazardous materials such as ammonium nitrate in warehouse 12. The explosion exposed serious management and safety failures. As a result, much of the port infrastructure was destroyed, causing major disruption to supply chains and the national economy. The third one is the technical personnel and engineer. Technical personnel and engineer were responsible for checking the condition of port facilities and identifying safety risks related to hazardous materials. Although some risks were known, unclear authority and poor communication limited their ability to take action. This showed the challenge of decision making in large and complex organizations. The fourth one is emergency and healthcare responders. Emergency responders, including firefighters, paramedics, and healthcare workers, play a critical role after the explosion. They conduct search and rescue operation and provided emergency medical treatment. Many responders worked in extremely dangerous conditions and some lost their life while helping others. The fifth one is victim and residents. Victim and residents were the most affected stakeholders. Many people were killed or injured and hundreds of thousands lost their homes, jobs, or personal belongings. The explosion caused long-term physical, emotional, and economic problems for many families. The last one is international aid organization. International aid organization and foreign governments provided important support after the explosion. They supply food, medical assistance, financial aid, and temporary shelter. Their support was important for both immediate relief and long-term recovery efforts. Overall, the stakeholders' analysis show that the Beirut explosion affected many groups at different levels, from government institutions to ordinary citizens, and had serious social and
In impact analysis, we have two impact which is immediate consequences and long-term consequences. For immediate consequences, human health, high number of fatality, severe blast injuries like fractures, burns, deafness, and acute mental shock. For long-term consequences, chronic health issues like respiratory and musculoskeletal, long-term PTSD, depression, and burnout. For immediate consequences, economic USD 15 billion in property damage and immediate destruction of Lebanon's primary import export port. In long-term consequences, increased cost of essential goods which is food, fuel, rise in employment and long-term national economic burden. In immediate consequences, environmental, release of toxic dust, smoke and chemical particles, air pollution and inhalation risks. In long-term consequences, contamination of soil and water resources and hazardous conditions for construction workers. For immediate consequences, institutional and safety, exposure of systematic vulnerabilities in danger control and lacks of risk management. In long-term consequences, public loss of trust in government and potential for strike hazardous material, regulation, and OSH reforms. Okay, next, in ethical professional failures in OSH perspective. From an OSH perspective, the 2020 Beryl explosions was not merely a technical accident but the result of prolonged ethical and professional failures. The improper storage of hazardous ammonium nitrate without adequate hazard identification and risk assessment reflects a serious breakdown in safety management practices. Despite repeated warnings, responsible authorities failed to take corrective action, demonstrating professional negligence and a clear breach of duty of care towards public safety. Weak regulatory enforcement and ineffective safety governance further allowed the risk to persist over time. Ultimately, these ethical and OSH failures led to catastrophic loss of life, environmental damage, and infrastructure destruction, underscoring the critical importance of ethical responsibility and accountability in engineering and safety-related professions.
The 2020 Beirut explosion served as an catastrophic example of failure in governance and occupational safety, health and environment (OSHE) due to the improper long-term storage of ammonium nitrate. The tragedy was fueled by a rigid governance structure where bureaucratic procedure were prioritized over actual safety control, leading officials to ignore well-known risks. This environment fostered a culture of cost-saving over prevention, where the necessary investment for safe storage or disposal were neglected in favor of short-term financial concern. Furthermore, an internal organization focus superseded public responsibility, ultimately exposing both workers and the surrounding community to extreme danger. This lack of accountability and delayed safety action demonstrated how a poor safety culture can transform an avoidable risk into a national disaster. The primary lesson learned in the critical need to balance computerizing organization value and to strictly prioritize OSHA standards to prevent future crises.
Moving on to our decision analysis of the Beirut explosion in 2020, based on our research, there were several major failures in decision making. First, there was poor decision making in handling dangerous material, especially 2,750 tons of ammonium nitrate were stored improperly at the port for many years. Second, many safety warnings were ignored. This shows that risk management was not priority for those in power. Third, there was a major communication failure. Information did not reach the decision maker, so no action was taken even though they were repeated alert. Next, the long-term strategy was unsafe. It was a huge mistake to store such hazardous material so close to residential areas where people live and work. In the end, weak hazard planning turned a known risk into a massive disaster. Moving on.
Next is key recommendations. Number one is proper storage of dangerous materials. Dangerous materials like ammonium nitrate must be stored safely and they should be kept in a proper place with good ventilation and far from people and buildings. Next is regular safety checks. Safety checks should be done regularly because this helps to find problems early and can prevent accident before they happen. Number three is follow OSH rules strictly. All organizations must follow OSH safety rules, and if safety rules are ignored, strong action should be taken to stop future accidents. Number four is training and awareness. Workers must be trained on how to handle dangerous materials safely. Training helps reduce mistake and improves safety awareness. And the last one is emergency planning or emergency preparedness and response planning. There should be a clear emergency plan. Workers and emergency teams must know what to do if an accident happens to reduce injuries and damage. In conclusion, the Beirut explosion in 2020 was a serious industrial disaster caused by years of negligence and poor handling of dangerous materials. The explosion involved 2,750 tons of ammonium nitrate stored at the port of Beirut, which led to hundreds of deaths, thousands of injuries, and severe damage to homes and important facilities. The explosions also caused major social economic problems in Lebanon. This case, this case study shows that poor management of hazardous materials can lead to serious humanitarian and social consequences. The disaster not only destroyed homes but also put heavy pressure on the healthcare system due to the large number of injured people. In addition, Lebanon's economy was badly affected because international trade and investment declined due to safety and reputation concerns.
Uh, Eight-horn collision occurred on 24 May 2021 at 8:33 p.m. between stations KLCC and Kampung Baru. The collision was a significant rail accident involving an automated passenger train (TR-81) and a manual-operated empty train (TR-40) in a tunnel near KLCC. The incident resulted in 213 injuries, including 47 serious cases and a case primarily attributed to a human error and failure in an operational control center. Investigation revealed that the system's safety system were inadequate for managing the transition from automated to a manual control, leading to recommendation for systematic improvement in SOPs and communication. The Kelana Jaya line, originally known as Putra LRT, was Malaysia's first fully automated and driverless rail system that had maintained a spotless safety record for over 23 years before this incident. The crash caused significant public anxiety as it involved one of the busiest transit line connecting major hubs like Subang Jaya and KLCC. Public outcry for further intensified by the insensitive kissing each other remark made by the former chairman of Prasarana, Tajuddin Abdul Rahman, leading to a high shift dismissal and a major loss of public trust in automated transport technology.
Okay, next, in case investigation, in technical analysis. The LRT Kelana Jaya collision was primarily a result of both human and system failures. During nighttime maintenance operation, operational safety controls were inadequate and staff did not fully comply with established SOP. Miscommunication between control center personnel and train operators, combined with system limitations, contributed to the collision. From an Oshe perspective, the technical analysis highlights the critical need for robust monitoring system, strict adherence to procedures, and fail-safe mechanism to prevent accidents. Next, stakeholder mapping. Stakeholder mapping identifies all parties involved and affected by the accident. Operators and maintenance crews were directly responsible for safe train operations, while control center staff was responsible for communication and monitoring. Passengers were the most affected due to compromised safety and service disruption. Management and regulatory bodies hold accountability for ensuring OSH compliance and enforcing safety governance. This mapping underscores the ethical responsibility each stakeholder has in preventing accidents and maintaining public safety.
This section explains the rail regulatory framework in Malaysia using the 2021 Kelana Jaya LRT incident. Importance of regulation. Rail systems carry many passengers and use complex technology. Strong regulations are needed to protect public safety. The incidents show that rules alone cannot prevent accidents. Safety depends on how well the rules are followed during rail operations. The Land Public Transport Act 2010, this act makes operates responsible for safe operation. APAD monitors operates and safety compliance. Manual operation risk. After a signal failure, the train was operated manually. This increased the risk of human error. Other safety law, the Railway Act 1991 and the Occupational Safety and Health Act 1994 focus on safety and risk management. The incident shows weakness in managing risk during abominable situation. Professional responsibility, engineers must always protect public safety. Poor communication and unclear decision increase risk. In conclusion, the regulations are strong on paper but weak in practice. Better enforcement, training, and safety culture are needed. This section.
Next is culture and social impact. Number one is impact on society. The accident shocked many passengers and the public, reducing trust and confidence in using the LRT for daily travel. Number two is social media reaction. Photos and videos of the incident spread quickly on social media, leading to public anger, criticism, and concern about passenger safety. And number three is lesson for the future. To prevent similar incidents, proper training, clear communication, strict supervision, and safety awareness among staff are essential. And the last one is safety culture issues. The incident revealed weakness in safety culture, showing that staff did not fully follow safety procedures and relied too much on technology.
Okay, next I will discuss about ethical analysis. Ethical analysis can be divided into two, which is local professional ethics and also global ethics integration. Okay, first I will explain about local professional ethics. So, passenger safety must always comes first. Train operators and control center staff have responsibility to protect passengers at all time. In Klanajaya incident, allowing two trains to be on the same track were unsafe and should not have happened. This shows a failure to prioritize passengers' safety. Next, workers must follow standard operational procedure, which is SOPs, and communicate clearly. SOPs exist to reduce mistakes and keep operations safe. However, poor communication and failure to follow procedures caused confusion, which eventually lead to the accident. And the next one is I will explain about global ethics integration. So firstly, rail companies must follow global safety standards, not just local rules. International safety systems and guidelines exist to ensure reliable and safe rail operation. This accident shows that these global standards were not fully applied in this case. Lastly, a key global ethics principle is to prevent harm. This means using fail-safe system, proper automation checks, and ensuring workers are well trained. This is especially important when switching from automatic to manual control to prevent human error and accidents. That's all. Thank you.
Next is recommendation. Number one is improve safety management. A strong safety system with strict procedures must be followed at all times. Second, staff training. All staff should receive training on safety, communications, and decision making skills. Number three is better communication. Communication between control centers, train operators, and the public should be clear and accurate. Number four is continuous monitoring and technology. Safety should be monitored continuously with audio and updated fail-safe technology. And the last one is safety culture. A culture of collective responsibility for safety should be developed to protect everyone.
To wrap up, here are the five main points from our conclusion. First, the accident was caused by a mix of technical faults and human errors. SOPs were simply not followed. Second, the system was not ready to handle the change from automatic to manual driving safely. Third, there was a communication breakdown. The control center received wrong signals about the train's position. Fourth, this shows that safety laws are not enough if they are not practiced properly during a crisis. Finally, we must build a stronger safety culture. We need a better technology and better human supervision to prevent this from happening again. Thank you. To wrap